Hello, welcome to another IMUNES Basics tutorial. In this video, I will explain all the node types in IMUNES and highlight their distinctions. In future tutorials, I'll explain both basics and advanced configuration for each node type. Let's start with the most common ones. I've created a topology that uses PC, host, router, LAN switch, and hub node types. PC, host, and router nodes share some similarities, differing mainly in their starting IP addresses when auto-configure is enabled. So PC nodes start at 20, while host nodes start at 10 and router nodes at 1. Host nodes auto-start inetd daemon, while router nodes have IP forwarding enabled, and if configured, they run a Quagga daemon, which will probably be replaced by FRR in the future, and with the possibility of automatically configuring a RIP and or OSPF routing protocols. All three of them have the same configuration options in common: basic node and interfaces configuration. But router nodes have an extra IPsec tab used for creating secure tunnels between multiple routers. Configuring IPsec will be covered sometimes in a future video. LAN switch and hub are L2 nodes with fewer options compared to L3 nodes. LAN switch nodes behave like regular learning L2 switches, switching the packets based on their destination MAC address. Hub nodes broadcast every incoming packet to all of its remaining interfaces, and you can configure queuing discipline, length, and drop type for each interface in both hub and LAN switch nodes. The next group of nodes are click router and click switch nodes. The only difference compared to regular router and switch nodes is that these nodes are running click software modular router in the background. I've not used these nodes lately, so they are possibly buggy or not even working, so I'll check if they work or possibly remove them from the default IMUNES installation. NAT64 nodes are routers running a Taiga daemon for 6-to-4 stateless netting. Just like Click, NAT64 nodes are unmaintained for quite some time now, so I should check out if everything is working as intended. Moving on, we have RSTP switch nodes running a rapid spanning tree protocol daemon, simulating an L2 switch. You can modify some basic STP configuration parameters in the configuration tab and some advanced ones in the bridge tab. In filter nodes, you can specify packet patterns for each incoming interface and designate one of the several basic options for the packet, whether it's forwarding to another interface, duplicating, dropping packets, or skipping to any other action rule. The packet generator node does exactly that. It generates packets on its output interface. You only need to define the packet rate and set the raw bytes of the packet. Finally, there are external connection, external net connection, and external interface nodes. There's a subtle difference between those. External connection is used to connect to your host by creating an interface on it, and external interface steals an existing host interface and assigns it to IMUNES. This stolen interface can then be used for linking whatever it is physically connected to IMUNES topologies. You can configure basic stuff such as IPv4, IPv6, MAC addresses, and additionally you can create LAN tags on these stolen interfaces. External net connection nodes behave similarly as external connection ones, but they additionally create firewall rules on your host so that all traffic going through it undergoes NAT. This can be useful if you want to connect your topology to the internet through your own host's interface. And in order for this to work, IMUNES also automatically creates NAT rules on the interface of the node connected directly to it. That's it for this video. If you have any questions or comments, please leave them in the comment section below. Thanks for watching. See you in the next one. Bye.